All right, well, thanks for coming out this morning. I know that 9 a.m. wake up after a party last night was probably a little rough for some, but thanks a lot for coming out. My name's Bob Kinney. This is Sebastian Stormak. We're going to be talking today about building iOS apps with AWS services. Excuse me. There we go. So this is going to be a little, this is kind of a new format for us. We're going to do a workshop in 3 parts. It's going to be some live coding. Unfortunately, the demo is not available for you to play along and code along, but we'll make that available after reInvent. We'll take a break after each part to allow you to ask any questions about the content in that section. So let's actually take a look at what we're going to actually do today. So in part 1, we'll just overview the actual mobile services and SDKs, the offerings that we actually have. Then we'll talk about managing users and authentication with Cognito, the identity solution, as well as IAM. And then we'll talk about synchronization of data with Cognito. And then we'll talk about the scalability concerns and the costs associated with those services. In part 2, we'll talk about understanding the usage of your app and understanding engagement metrics with mobile analytics. We'll talk about how you can transfer and manage content in your app with Amazon S3 and the Transfer Manager. And we'll talk about how you can also share and store content with DynamoDB with our object mapper. Then we'll also talk about scalability and cost concerns with those solutions. Finally, in part 3, we'll be a little bit more hypothetical, but we'll talk about SNS Push, our Kinesis recorder, Elastic Beanstalk, and some additional advanced topics of extensions to the application we're going to show. And again, we'll talk about scalability and costs. We're going to actually do some functionality inside of an app, and this app is called, we're calling a Notes app. And the app is intended to allow you to take pictures and assign a note to them, synchronize that data, and also geolocate it. You can make those photos public or private, and share them with your friends. So we're going to have login and identity. So we're going to enforce a login inside of this application. We're going to take pictures, upload them, and then track usage of the app. So when you're building an application, you're going to have to do a lot of different things. And these are things that you kind of have to do every single time you build a mobile app. The first thing is obviously you want to authenticate your users so you understand whether or not who your users are when they have access to the resources that you define. You want to be able to synchronize data so that if your user logs in, they can access it wherever they log in. You want to analyze the user's behavior. You want to see excuse me, when your users are coming back and how often they're coming back. You want to track retention. You also want to be able to store and share media for those users and allow them to access that data. You want to deliver it back to them in a fast and easy way. You want to be able to engage with your users, and if they're not coming back, push notifications to them so that you can get them to come back. And then you also want to be able to allow you to store shared data that can be accessed by any user in the system. And then finally, you also want to be able to store and track real-time data from your mobile device. AWS Mobile has a bunch of offerings that actually solve a lot of these problems. So the top portion here is our mobile-specific services. So Amazon Cognito, which is a product that I work on, Mobile Analytics and Amazon SNS are mobile-focused services. So these were built with the mobile developer in mind. But then we also have our mobile SDKs, iOS, which we're talking about today. Android is next door. Which has specific connectors for other services such as Kinesis, S3, DynamoDB, SES, and SQS. So with the mobile services and the SDK, we can actually solve all of these common problems, the undifferentiated heavy lifting, as we call it. So first up, let's talk about how we can authenticate users with Amazon Cognito. Cognito is, again, a product I work on. It's got 3 main components. First is the identity component. So we allow users to log in with any public provider, as well as your own authentication system. The system also supports unauthenticated guest access, as well as transitioning from authenticated to, or unauthenticated to authenticated access. Because it's built on top of Web Identity Federation, we get secure access. So we can have credentials that are pinned to specific users, and we can limit their access to only the resources for them. Finally, we also have a data synchronization component as part of Cognito. So once the user has an identity inside of the system, we give them a small amount of key value pair storage that can synchronize across their devices. As I mentioned, so Cognito supports multiple login providers: Facebook, Google, Amazon, OpenID Connect, plus custom providers via developer authenticated identities. And it helps you manage the best practices, so you no longer have to embed credentials inside of your mobile applications in order to access other AWS services. One of the best features, at least I think, of Cognito is this unauthenticated guest access. So if you want to have a read-only access or a guest user access for your users and access a subset of resources, you can do that with the service. You can save data in the sync service. You can access files in S3. And then when the user actually decides to log in, they can actually continue to keep that same identity and keep all of their same data. Again, it's we're recommending Amazon Cognito as a best practice for mobile apps now. It allows you to actually get credentials to the device without embedding them in. We can give you short-term credentials that refresh and are pinned to the individual user. So let's talk a little bit about the identity data model. At the top level, we have your AWS account. Inside of that, you can create any number, up to 60 identity pools. And the easiest way to think about an identity pool is a relation to an app. That's not to say that you are restricted to using an identity pool per app, but it's the easiest way to think about it. Inside of the application, you can have any number of identities, and that represents an individual user inside of the system. And then each identity can have 0 or more logins associated with it. And if the identity does not have any logins associated with it, it is a guest or unauthenticated user. And if it does have, in the instant it does have a login, it becomes an authenticated user. So getting started with Cognito is actually really easy. We just have to log into the console, create an identity pool, walk through the wizard, and it will actually set up and give you some starter code that you can integrate into your app immediately. So that's actually what we're going to do right now inside of our app. I'm sorry? I'm sorry, many apps in what sense? So you can definitely use the same identity pool across multiple apps. All right, so I've gone to the console and I've opened up the Cognito getting started. So I'm just going to go ahead and click Get Started. I'm going to give my identity pool a name. And then I'm actually going to use log in with Amazon later. So I'm actually just going to go ahead and pre-populate that now. I'm just going to grab that app ID from my cheat sheet. And then I'm also going to enable unauthenticated guest access just so that I can test some stuff out while we're building. So what will happen when we get to the next step is that I'm going to be able to create, or the console is going to prompt me to create 2 roles, one for my authenticated users and one for my unauthenticated users. We recommend that you actually split the 2 permission sets so that you actually restrict your unauthenticated guests to a more limited set of permissions because there's fewer fewer verifications of those unauthenticated users. So I'll just click Update Rules. And then now I've come to the final step where I've actually got some starter code that I can include inside of my app. So here, I'm just going to copy this credentials provider. I'm going to bring it over to my app. I'm going to create my credentials provider inside of my app. And then I'll go back here and just take a look at this. So that we also have this concept inside of the Moble SDK of a service configuration. And this provides a default configuration set, so which region we want to use, as well as what credential provider we want to use. And because we just created our Cognito credentials provider, we want to use that. So I'll go ahead and set our default configuration. And it's important to note that in the iOS SDK, once you set the default configuration, it can't be overridden again. But that does not mean that you can't use a different configuration on different service clients. You just have to create a different instance of a configuration to then instantiate that client. So my class needs to keep a reference to our credentials provider. What's that called again? It's called credentials provider. Of course it is. So now that I have my credentials provider and I have initialized it, we want to make sure that we're actually getting an identity. So what I'm going to do is I'm actually going to call a method called getIdentityID. And this method actually returns a BF task, which is from the Bolts framework, which is what the iOS SDK is built on top of. And this method ensures that I have a local cached identity ID for this user. And because it's a BF task, I can actually continue with block, and then I can actually log the identity ID on my credentials provider. And then the identity ID itself gets returned either in the results or it's stored inside of the credentials provider on the identity ID property. So now that I have that, I'm going to go ahead and start my simulator. Oh, I think it tried to start it on my phone instead. Where'd you go, Xcode? Power of live demos. So what I'm hoping to actually show here while I'm waiting for Xcode to actually restart is that we can create a new identity, get credentials, and then it will actually show up in the console. So hopefully we can get this going again. syntax code. There we go. Full screen mode fail. Okay. Sorry about that, folks. Okay, so click allow here, yes. Okay. All right, so this new version of the app unfortunately doesn't call this. Of course it does. So I'll actually move on to the authentication piece. Now we'll actually try to integrate our login with Amazon SDK. We're going to use login with Amazon, and when it comes back, we're going to get an access token. And we need to actually assign that access token to our credentials provider so that we can associate our identity to the login with Amazon user. So the way we do that is that we have, on the credentials provider, we have a logins map. And that's an NS dictionary. Oh, come on. Does not want to behave today. Okay. And what we do is we set that logins map with the key of the domain of the provider that we're using, and then the values are the tokens that we get back from those providers. So in this case, our provider is www.amazon.com, and our token is actually going to be this token that comes back from the API result of the Login with Amazon SDK. I'm not going to show integration with that today, but there's, plenty of examples online of how to integrate with that. All right, so now that I've got that, I'll go ahead and restart my app. Actually, before we do that, also, what we'll want to do is actually want to make sure that we assign that token and assign that identity to that, the token to that identity. And the way that we can do that, and we can force that, because the credentials provider is lazy loaded, we can actually force a refresh on the credentials provider. And the refresh method, it also returns a BF task. And its job is to actually make sure that the credentials are fresh. So it goes out to Cognito and STS, and I'll go over the flow in a bit, to actually make sure that the credentials are there. So again, it's a BF task, so I'll do a continue with block. And then I can actually, once again, I'll just log our identity ID to prove that we got credentials. always return nil from your BF tasks. Okay, so let's try that again. So now when I click the login with Amazon, it's going to redirect me to the browser where I will be able to log in with Amazon. Oh, that was dumb. Now I'm going to get redirected back to the app. Why aren't any of my logs coming up? There they are. And so now I can see in my logs that I have an identity ID, and if I go back to the console and look at my identity pool again, I can see that I now have one identity, and that identity is a login with Amazon identity. So after a few hiccups, you can see that we were able to get authentication integrated. So let's just review some of the code that we actually put in. So we created our credentials provider, and the credentials provider has 5 properties that we assign to it when we create it. The first is the region. So Cognito is available in US East 1 and EU West 1 currently. And then, so that will actually decide which region we hit and where our identity pool is. Second is our account ID, and that's your AWS account ID that would be associated with your identity pool. Then we have your identity pool ID, which you can get from the console. And then the final 2 things are our 2 role arms, our unauth role arm and our auth role arm. And we'll use the unauth role arm when we're a guest user, so we don't have any logins associated with the credentials provider. And as soon as we actually add anything to the logins map, we'll use the auth role to get the credentials. So then after we created our credentials provider, we set our configuration. For our purposes, we were setting our default region for other service clients to be US East. Even though Cognito is only available in US East, you can set you can set the credentials provider to use US East or EU West 1. But then you can set your default configuration for other service clients to be another region. So then we set our default configuration so that we can use that for other service clients. Then once we have a token from a provider, we can assign it to our logins map. And what you see up on the screen is actually our enum form of the credentials provider map. And so we have constants for login with Amazon, Facebook, and Google. But you can also just, as I did in my example, use the bare domains. So I mentioned that the credentials provider handles the Authflow. So let's walk through that really quickly. So the first thing that happens in the authenticated flow is that you log in with your provider, in our case, login with Amazon. What you get back is a provider token. So in the case of Facebook and login with Amazon, that's an OAuth token, an OAuth access token. In the case of Google or another OpenID Connect provider, it's an ID token, an OpenID Connect ID token. Then we pass that to Cognito as part of a getID call. And if this is the first time we've ever seen it, we will create a new identity for it. If it's a returning user, we will retrieve that identity. And we will, after we validate that the token is valid, we will return that identity ID back to the device. The credentials provider will actually cache that identity ID for you in the keychain. And then once it has that information, it will pass the token again along with the identity ID as part of a getOpenID token call. And then Cognito will once again validate that token with the identity provider. And assuming it's valid, it will return an OpenID connect token for Cognito for that identity. Finally, the credentials provider will call STS, or Secure Token Service, with that OpenID token. And STS will validate it with Cognito. And assuming that it is valid, it will return AWS credentials. So all of the stuff under the gray box is handled by the credentials provider. So the only thing you actually have to implement yourself is the login flow, for the provider. So now that we have our login and our authentication handled, let's talk about how we can actually authorize access and restrict access. So the way we do that is actually via IAM Roles and Web Identity Federation. If you're not familiar with IAM Roles, it's actually the way that we deliver temporary credentials in a various number of ways. There are two policies associated with the role. One is the trust policy, which defines who can assume that role. And the second is the access policy, which defines what resources that user has access to after they have assumed the role. There are three main types of roles. AWS service roles, such as for EC2 or any number of other services. Cross-account access, which allows other users to access resources in your account. And then finally, identity provider access, which is what Cognito uses. So I mentioned that we create two roles by default, unauthenticated and authenticated. If you don't enable one of those features, so if you don't provide authentication access when you create your pool, or you don't enable unauthenticated guest access, one of those two roles won't get created for you. But in the case where I created both an app ID from Amazon and unauthenticated access, I got both roles. By default, we give you access to Cognito Sync and the analytics service, but you can extend it to add any other services you care to. And the best part is that we support fine-grained access control with policy variables, so you can actually limit access to your individual users. So what you see up here is our default trust policy for an unauthenticated guest, an unauth role. This part up here, the principal, defines that we're trusting Cognito specifically. The second component, this condition on the odd field, is trusting our identity pool. Because Cognito uses OpenID Connect, we actually have, we follow the OpenID Connect spec, so this is the audience field of that token that we vend. Finally, we also use the AMR field to define what kind of authentication was used. So in the case of guest users, it's set to unauthenticated. For authenticated users, it's set to authenticated, but it also includes a list of any authentication methods used. So in the case of our example, we would also have www.amazon.com. So this is the default access policy that we give you from the console. By default, like I said, we give you access to mobile analytics to put events, and then also access to the Cognito Sync service. Excuse me. You'll notice here that we have a star policy. It may seem too permissive, but Cognito Sync actually has some additional protections to limit access across identities. So this is actually OK. So let's talk about a use case where we might want to use policy variables. So we want to have our users upload photos. And then we also want to have them be able to index them in DynamoDB. And we want to allow them to be able to create, modify, and update, but we don't want to allow any other users to have access. So what you see here is actually an effective policy for S3 that will allow you, the top part would allow you to write, read, and delete. And the bottom part would allow you to list those files based on a prefix. And the magic part is this variable here, cognito-identity.amazonaws.com:sub. And this will be replaced with the identity ID, which was that GUID that I was showing you after we got our credentials. Same thing works with DynamoDB. You can use the you can use the policy variable with the leading keys to actually restrict access to a particular hash key. So now I'd like to talk about synchronization with Cognito. So when we were building the service, we talked to a lot of customers, and they told us that they were they were interested in implementing sync, but they didn't necessarily want to spend a lot of time to doing it. Managing offline access, managing synchronization across platforms was a lot of heavy lifting, and they didn't necessarily want to have to do it themselves. So that's kind of why we built Cognito Sync. So you can think about a news outlet who might be interested in making the same data available from both their mobile versions of their applications as well as their website. We can actually synchronize that data as long as the user logs in, and they can have access in all of their devices. Additionally, we've also seen a lot of developers using Cognito Sync for game state. So users can excuse me, use their tablet and play the game, and then if they go on the run and they want to continue to play on their phone, they can do so. So Sync has a few different nice features. So we can store a reasonable amount of data. We have, and I'll get to the limits in a second. We also have offline access, so all of the data is cached locally and then synced when changed. And you don't have to write a backend to actually manage all of this. So the sync model extends the identity models. So again, we have our AWS account at the top, our identity pools up to 60, unlimited number of identities. And then inside of an identity, each identity can have 20 data sets, which is a collection of records. And the records can be up to, or the data sets can be up to 1 megabyte in size. So effectively, you have 20 megabytes of storage per user. So I'll actually go ahead and add data sync to my app now. Not switch. All right, so I'm going to fill in some code here in this sync manager, sync manager client that I've created here inside of my application to actually manage all of the interactions with the Cognito Sync service. So the first thing that I want to do is get a handle to one of my data sets, and that's actually quite easy. I just get a handle to the data set by getting first a handle to my default Cognito client. What's going on? Early morning coding. So again, so I get a handle to my AWS Cognito dataset by getting first a handle to my default Cognito client. And because I'm using the default configuration set with my credentials provider, I can always just call AWS Cognito, default Cognito, and that will have the default region and the default credentials provider already set for me. Then I call open or create dataset. which will either create or open, as the name suggests, the data set that I've given as a name. And here I'm just going to use this Cognito demo.locations, which is going to be a common data set that I'll use throughout the sample. Now that I have a handle to my data set, I can call synchronize on it. And as with most methods in the iOS SDK, it returns a BF tasks, so I can do a continue with block to handle any returns. If the task has an error, then it failed, and I can log that and handle it if I need to. Log that error. Otherwise, it succeeded, and I can just also log that as well, just as an informational message. So that allows us to actually synchronize the data. So synchronization itself doesn't actually return any data. It just makes sure that your local cache is in sync with the cloud. The sync actually does a pull down from the cloud for any updated changes, handles any conflicts locally, and then pushes any changes back up to the cloud basically as a single operation. All the synchronization happens as single, can be considered atomic operation. We don't actually mark the data as clean until we've actually ensured that all of the data is pulled and pushed. My app is going to expect to be able to pull data out of my data set. So I'm going to also, in this Cognito sync initialize method, do the same thing. So I'm just going to actually go ahead and copy this part. But in my return method, rather than simply just returning nil from my task, I have a callback method that I'm going to call. And what it's expecting is the array of objects inside of my data set. And that's easily accessed by just calling dataset get all. And then it's specifically looking for the values, not the keys. So I can just call all values on that array, or dictionary, excuse me. So get all will return a dictionary of all the key value pairs. You can also do get all records if you're interested in actually seeing the metadata associated with those records. But in most cases, get all will handle most of your use cases. OK, so then also, if I want to be able to clear all my data, so if the user wants to say wipe out all of my data, that again is easy. So we just need to get a handle to my data set, and then call dataset clear. So that clears all the data locally. In order to actually persist that to the cloud and delete it all locally, I still have to synchronize it. I don't need to wait for that to complete, so I won't use a continue with block here. Now, if the user logs out but doesn't want to wipe their data, so that it's a shared device and they want to allow somebody else to log in, you can wipe all the local data by using the AWS Cognito, default Cognito wipe method. And that will make sure that all of the cached local data for that user is deleted from the local cache. All right, so we've talked about how we can synchronize, remove, and wipe data. So let's actually get to actually adding and removing data. So again, we just need to get a handle on my data set. Then I can call, sorry, brain fart today. So the data set has set string for key. which allows you to set the value basically as if it was an S dictionary. So then I have my passed in data item and my key. And because this is operating on the local data set, it doesn't use a BF task. It's not asynchronous. It actually hits the local cache, writes, and then immediately returns. And then the same thing for our remove data set. We can actually just call remove object for key. So then also, the one last thing that I'm going to show as well is actually push synchronization. So by default, all synchronization is polling. This means that you have to constantly check to see whether or not there's any new data. But we actually integrate with SNS so that you can actually subscribe to receive updates when other devices change your data set. And then you can pull the data on demand. So the first thing I need to do is actually, on the default Cognito client, I need to register my device. That actually takes the raw device token that's returned from our registration from the iOS SDK, from the Apple. And then we also want to subscribe to receive updates. So subscriptions are based on data sets, so you can either opt in to receive partial updates for single data sets or all data sets. So I'm actually going to subscribe just to my data set. If you want to subscribe to all of your data sets, you can actually do that through the default Cognito client. There's a subscribe all. There's also an unsubscribe all to stop receiving notifications. And that's it. So the first thing before I try to test push sync is I'm going to go back to my console and edit my identity pool to add the support. So this is only available after you create your identity pool. You can go in and add the support later. So I'm going to go ahead and I don't have a role already created. We need to give Cognito Sync access to push messages through my already configured SNS topic, or SNS application, rather. So I'm going to allow the console to create a new one for me, at which point it's available in this dropdown. And then again, I already configured a platform application, so I'm just going to go ahead and select that. That's already configured for this application. Okay, great. So first things first, let's go ahead and start this up. On the simulator. Oh, did I lose my Xcode again? That is frustrating. Does anyone know the hotkeys to get back to the full screen view? That's for Xcode. I'm sorry. You're absolutely right. Okay. This is what I'm saying. Did I close the window by accident? That's embarrassing. All right, so I'm going to deploy this app both on the simulator and on my physical device because I need to be able to actually demonstrate the push notifications. So first, we'll try to get it running here. All right, so if I try to click on plus and I can add a note here. So then this gets put into the local store, pulled to refresh will synchronize, and then I can do that. So now let's try to launch this on my device. Did it close again? The play, not. So let's relaunch it here. Sure, absolutely. While we're waiting, might as well.
So I guess you're using the default Cognito client, which has the region information in it.
Yes.
But if I, let's say, want to synchronize, or if I want to use the services in a different region, like say US West, I can still use the same identity pool, but
You cannot. So, with the exception of Cognito Sync, every other service client you can use across the services with a different identity pool, an identity pool in a different region. Because it's a bundled service, the Cognito identity pool needs to be in the region that you're actually using the sync service. So if you want to use sync in EUS1, your identity pool needs to be in EUS1. Correct. Yep. Yep, absolutely. So just to repeat the question, so the question was about whether or not you can use the default, or whether or not you can override the client region for Cognito Sync. And as I said, because the services are bundled together, the identity pool needs to be available in the region you're trying to sync to. So now I have the app running on my my physical device and my simulator. Hopefully, as long as we've done our jobs right, we should be able to do a push sync from here. So if I add a new note, and then synchronize, hopefully what I should see on the other end is that we actually get the sync. Or maybe not. All right, so let's just try actually just restarting the app real quick. Registration might not have gone through correctly the first time. This is part of the reason that the sample is not available today. We're still working out some of these little kinks, so I apologize. Okay, all right. So let's try this again. So actually, a great way that you can see whether or not the registration has succeeded, because we're using SNS under the hood and we're using the SNS resources in my account, I can actually go and see whether or not the user is actually registered already. So I can quickly go to the SNS console. Check my app. And I have an endpoint, so it's successfully registered this time. So hopefully our second test will work. So this time I'll actually delete an object and sync. Oh, come on. Of course, the live demo doesn't want to work. You'll have to trust me. If you saw my cohorts demo 2 days ago, the feature does in fact work if you code it correctly. The idea is that we send a silent push notification that can be handled by the client, and then you can initialize the synchronization live, and you would be able to update. Fortunately, can't update it. Well, oh yeah. No. So we only need the one registration endpoint because you actually can't send push notifications to the simulator. So the question was, do I need 2 endpoints? And again, we only need one. So basically what should happen is that because I've registered with the physical device and then I push an update from the simulator, this physical device should be able to get the update. Same is true for mobile and or for web. So the demo that my cohorts actually showed the other day, they actually updated the data set from a browser application, and the device actually received the update. So that's data sync. So it should be milliseconds. Obviously, there are the vagaries, and the question was, how long should it take? So there's the vagaries of delivery of notifications by the push provider, Apple in this case, whether or not your device can actually connect to the push endpoint, but it should be reasonably fast. The synchronization itself might be a little bit longer, but the delivery of the notification should be pretty quick. So the question was, what was the size, the limit of the size of the data? It's 1 megabyte per data set, up to 20 data sets per user. So we'll actually have, and the question was, do we do retries? And we're going to have a section on SNS specifically a little bit later in the section, and we'll go over that. But there are retries on that. So just to review the sync code, again, everything's kind of pivoted off of our Cognito client and our data sets. So we get our handle to our Cognito client by calling default Cognito. We get a handle to our data set by calling open or create data set. We synchronize our data set by calling synchronize, which returns a BF task, so we can continue with block and handle callbacks. When we want to update data, We do set string when we want to remove. We do remove object. We can clear data sets, but we have to synchronize afterwards. And then we also can wipe all the local data. So talking about the scalability and costs, we've already kind of mentioned some of the limits. No limit on the number of identities. And the other important thing to note is that because we are recommending it as a best practice for mobile applications, all of the access, the login, and identity management stuff is all offered free of charge. If you don't use any of the synchronization features of Cognito, you don't have to pay anything. Then inside of the identity itself, 20 data sets, 1 megabyte apiece, and then the actual, so free tier for Cognito is 10 gigabytes of space, 1 million synchronizations per month. And then after that, it's 15 cents per gigabyte and 15 cents per 1 million syncs, I believe, or 100,000 syncs. Yeah, sorry, 10,000 syncs, excuse me. 10,000 syncs, 15 cents every 10,000 syncs. So that's actually the end of our first section. We've obviously been taking questions as we've been going along, but does anybody else have any other questions about this first section? Yes? Yes, so most application logins, login with Amazon included, uses sort of a all-auth single sign-in flow where it redirects to a single sign-on app. In the Amazon case, it redirects to the browser, but in Facebook, it redirects to the Facebook app. Then it redirects back, and then when you get redirected back, you get that token. If you wanted to write your own authentication system, you can certainly do that inside of the app. Unless it is actually an OpenID Connect flow, you will have to follow a different flow, what we call developer authenticated identities for doing that. So you would actually then have to manage the authentication flow on the back end to call Cognito. Any other questions about Cognito, sync, or identity? Yeah, so the question was, what about Android and web? So we have an Android SDK, we have a JavaScript SDK that we actually just launched last week. All of these work with the same backend, same authentication infrastructure, so you can get same data access on all three platforms. Yes? The question was whether or not we have any concept of grouping of users. Not currently. Any other questions? Okay. So let's go ahead and move on to part 2. So let's talk a little bit about analyzing user behavior with mobile analytics. So as developers, we use a lot of different kinds of tools. Obviously, some of the most popular ones are cloud computing, which obviously you all know because you're here, as well as analytics tools. So analytics and cloud computing are among the 10 most popular tools that developers use today. So when we were actually going out and building our analytics service, we talked to a lot of customers, as we do, and they told us that they wanted to be able to get their metrics and their analytics in a timely manner, and they wanted to own that data, just as with any other service. So we have our mobile analytics platform. It has an SLA of within 60 minutes, the data that you send up from the device will be available in a dashboard. So the SLA is 60 minutes. Currently, it's actually the actual effective speed is actually much faster. You can expand and scale. So obviously, we're just like any other AWS service. We can scale up. The data is collected and anonymized, so there's no potential leak of information for your customers. So here you see a default dashboard, and these are a bunch of the basic key metrics that you get sort of out of the box with the mobile analytics platform, standard MAU, DAU, new users, sessions, et cetera. So additionally, we also have retention metrics, so you can track to see whether or not your users are coming back. And best of all, we actually have custom events, so you can actually add additional events that you might be interested in tracking, whether or not it's you're testing whether or not someone's using a new feature, et cetera. Yes? Not currently. So the analytics platform uses the MAU model that a lot of other analytics platforms use, which is basically actually the device installation, not a individual user, identified user. So getting started with analytics is also pretty easy. Go to the console. It uses Cognito as the mechanism for getting credentials to the service. It's available inside of the SDK, and then you can immediately start engaging and adding metrics. So I'm not going to do a live demonstration of recording events, but here's an example of how you would actually create a custom event with our SDK. So the first thing that we do is we get our analytics client, and the analytics client is defined by our app ID, which you create inside of the console. And then we create an event client from that. Then once we have our event client, we create our event type, which is our specific event we're trying to track. Then we can add specific attributes to that, and we can add any number of attributes. And then we record the event. So the nice thing about the analytics client is actually it does batching. So you can emit any number of metrics, and then once it reaches a certain threshold or in terms of size or time, it will batch those up and send them as a single request. All right, so let's move on to S3 for storing and accessing data. So the way we do that with our iOS SDK is that we actually have a nice feature called the Transfer Manager. And for larger uploads, it will actually break apart and do multi-part uploads. It will retry parts. Unfortunately, we're at the mercy of S3, so the smallest part that we can do is 5 megs. So anything smaller than that will be a single upload. It is fault tolerant, so if it fails for any reason because the network dropped, it will retry. We can pause and resume. Again, for uploads, we can only do that on 5 meg blocks. For downloads, we can pause and resume at any point. And it's been obviously optimized for the platform. So what I'm going to do now is actually integrate the S3 Transfer Manager into my app now. Okay. All right, so the first thing that we need to do is we need to create a request for an upload. And so the S3 Transfer Manager includes a number of request objects, including upload request. So I create my request. And then we need to give it the information that we need to actually upload. And so the first thing that we'll need is, actually need to give a variable name. So the first thing we need is a bucket. So this is the S3 bucket that we actually want to upload to. And this is the bucket that I've already pre-created for this purpose. Then we also need a key. I have a little helper method here that will actually give me the key for the file that I want to do. And that is going to be based on the URL, which I, of course, removed. Okay, I'm going to have to go back and get that for my cheat sheet. Okay, and then so this also just allows me to do visible to all. So when we do public photos, we need to separate those out from the rest of them so we can make sure that our private photos are private and our public photos are actually public. It's just the URL. Sloppy. All right. So now that we have our key and our bucket, we also obviously need the payload of the data that we're actually trying to upload. And the transfer manager can actually read that from a file directly from disk. Let's fix that first. So then we set our body to be the a URL that is represented by the URL that file that we're local on disk. And then the S3 transfer manager will actually open it, manage the stream associated with it, read the bytes, and send them up. So those are the three things that we actually need to do in order for our request. Now we need to get a handle to our transfer manager. And as with the Cognito client, we can get a default instance of this transfer manager, which uses the default configuration. So to go back to one of the earlier questions, if I wanted to use an upload to a different region, I can initialize it with a different configuration with a different region and upload photos to any region that S3 supported, which is all of them. So then actually, now that I have my request and my transfer manager, all I have to do is actually call upload with the request. And a message you'll hear me say a lot is this returns a BF task, so I can say that I can continue with block. As an example, I can say that if I do AWS configuration, or service configuration, I could create a config here. And then you can specify a region here. And then I can specify any region and any credentials provider from there. Then after I have that, I could then, instead of calling default transfer manager, I could call transfer manager okay, so it doesn't support that one. And then you can init it with the configuration, and then you can give it an identifier. So that's how you would do that. Again, I'll put in some basic error handling here. And then, assuming that it succeeds, I have an onSuccess handler that's going to just handle some UI components inside of my app. And the onSuccess expects to get back the key that I uploaded, so I'll just pass that back. Always make sure you return nil. And then I'll actually just move this deletion of my file, temporary file, into my success handler. Make sure I return the key. OK, so that will be upload the file. And so then that will put the object in S3. I will get back a key path that I've assigned to it. But then how do I want to get it back? So the transfer manager is good for downloading files. I would highly recommend it for downloading large files. But if you want to support background transfers, unfortunately, the transfer manager does not work with Apple's background downloads. So we'll actually walk through how you can use our pre-signed URLs to actually get a URL that you could then hand to a URL session, which then could be used inside of a background download. So much like the transfer manager, we have a special class that handles our pre-signed URLs, which is the S3 pre-signed URL builder. So I'm going to get an instance of that. And then I need to construct a request for that, for the pre-signed URL. Brain fart. Too many of those this morning. Get pre-signed URL request, of course. All right, so our request is called S3, AWS S3 get pre-signed URL request. Create that. And then the request, our pre-signed URL request, much like our upload request, will need a bucket. It will need a key. Which is just our key. But unlike the upload, we don't have to supply a stream. So because we're just building the URL request, what we're going to get back is a URL that we can then fetch content back for. So that's really all we need is a bucket and key for this request. So then on our builder, we call get pre-signed URL with the request. This returns a BF object, or a BF task rather. So we can continue with block. And then what comes back inside of the task is actually the URL that we can actually use to fetch, if I remember correctly. Yep. OK. So I'll put in some basic error handling again. And then if we don't fail, then we actually have the URL, and then we can actually get that data. I've actually, I don't know if anybody noticed, but I'm actually doing this as obviously an asynchronous dispatch request with GCD. Obviously, don't want to be doing this fetch on the main thread. You could also do it with a BF task, but we just decided to use GCD here. My client is expecting to get the contents of this and store it. We're also storing it in a cache, at a local cache, so that I don't need to fetch the contents every single time. So I need to make sure that I actually store that data inside of my cache. And I'm just going to go ahead and get this from here. So I fetch my data with my URL, which I got from my pre-signed URL request. I'm going to turn that into UI image and store it in an image cache so that I can get it later. And then I just need to call our onSuccess handler when I'm done so that I can actually proceed with my UI. So while we're here, we'll also do some other S3 functionality. So if we want to actually delete files, so Transfer Manager handles uploads and downloads. If we want to do any sort of low-level operations with the objects in our S3 bucket, we'll have to drop down to our low-level interface. So that's what I'm going to do now. I'm going to get a handle to my S3 client, which is just AWS S3. And then my delete request is going to be AWS S3 delete object request. Like our pre-signed URL, all we need is a bucket and a key. And our bucket's actually passed in for us. So then after I've created my request and I have a handle to my client, once again, all I have to do is call the appropriate method on our service client with the request. This returns a BF task, so I can call continue with block and do some basic error handling. Oh, thank you. Thank you. Would have actually gotten a validation error if I had tried to actually do that with the key included inside of it, so it's fine. Anyway, all right, so let's get this rest of this coded up. All right, if we succeed, we'll remove our object from the cache. Always return nil when we're done with our BF task. Okay, so now we've got get, put, delete, and that's pretty much all we need to do with S3 for this particular application. So let's go ahead and see if we can give it a try. Any questions while we're waiting so far? Yes. So this is the framework is the iOS SDK. It's built on top of the Bolts framework, which actually is from Parson Facebook. It's a really nice asynchronous library that allows us to kind of do this chaining that I've been doing in a lot of the different service requests. I should also mention that the SDK also uses CocoaPods, so you can actually pull down the SDK and all of its dependencies via CocoaPods. We also have binary builds, but we actually recommend CocoaPods, particularly if you're going to start integrating with other SDKs, because that way it'll manage the dependencies a little bit better. All right, so let's go ahead and see if we can add a photo. So that's actually a bug in the app. It's trying to load the photo that doesn't exist on the note that doesn't exist. Oh, lovely. Let's try that again. All right, so let's select one of these pre-stock photos. Make sure that we say add a note. Oh, so our upload failed. So I wonder why that would be. So I'm going to harken back to what I was talking about earlier, where we said that by default, our roles only have access to Cognito Sync and the mobile analytics client. So we actually don't have permissions to actually upload to our bucket. So what I'm going to do is go to my console. All of this is managed through the IAM console. I can go to the Roles tab. I can select my workshop role. I'm going to be looking at my auth role. And I could update the existing policy. Personally, I actually like to attach new policies when I need to add new functionality. That way I can delete and remove functionality a little bit easier. So I'm going to go ahead and click Attach New Policy, select a custom policy. I'm going to grab that from my cheat sheet. No, sir. I'm not going to code that by hand. And so you can see here what I'm allowing to do. I'm not actually going to ever list files directly from S3, so I'm only ever getting, and deleting objects. And then I'm giving it specifically to my bucket, to the pictures, and public and private prefix. So private photos that I don't share publicly will go into the private folder. Public photos that I want to share with other people will go in the public folder. So folders don't actually exist in S3, so they just exist as prefixes. The console kind of gives you this notion that folders actually exist, but they don't. It's just a special prefix. So the only thing that needs to be recreated in this case is the bucket, and then the prefixes will just work out afterwards. Okay, so now that I've attached that policy, I'm going to go ahead and restart my app so I can reforce credentials to be refreshed. Because I've got cached credentials for the role as it existed previously, I still wouldn't be able to upload. So I'm going to go ahead and stop it on the simulator and restart it, because I had that refresh in the beginning of the client, so that I will force a refresh so that it'll pick up the new policy. Okay, again, let's select a photo. Make sure we give it a note. So the picture is uploaded, and I've got a pre-signed URL. Aha, okay, so my mistake. So our pre-signed URL has one additional piece of information that I forgot to include, which is our expiration. So obviously, if I didn't have an expiration, our pre-signed URL would be basically make our photos public. So we actually want to add an expiration date to our pre-signed URL. So let's go down to our pre-signed URL. I am, just for the sake of time, going to grab my expiration code from here. So our expiration will be 10 minutes. So that's a reasonable amount of time to actually allow the upload to, or the download to complete. But you could certainly tune it to whatever you wanted. And then we just set the expires field on the request to be the expiration. Restart our app, and then hopefully when it comes up, it will download that photo and put it in that cache. Any other questions, again, while we're waiting for Xcode to do its thing? So if you don't return nil from the BF task, you actually, it'll cause an execution failure. So depending on how nested your BF task is, the Xcode may or may not be able to show you that. So in the base case where you just have one continue with block, you'll actually see a warning or an error and it won't compile. But if you have a lot of nested tasks, so you can continue to do that continue with block forever basically, as long as you return another BF task, Xcode will eventually get confused and not be able to figure that out anymore. The problems with live coding. So I did forget one other thing with my pre-signed URL request, which is the HTTP method. So obviously we're doing a download. Hopefully that will take less time to link this time. All right, great. So now we've got our images finally loaded. So again, we can download photos, we can get pre-signed URLs to put them in the background, and we can upload them with the transfer manager to manage our uploads. So let's just review some of the code. Again, for our transfer manager, we can create upload requests. There are also download requests, but again, if you want to support background transfers, the transfer manager is probably not the best solution for that. Well, it's definitely not the best solution for that. So then when we create our upload, we need a bucket, a key, and content, which is our data, our file. When we want to actually upload, we get a handle for our transfer manager. We call upload on it and handle the BF task. When we want to download, again, we'll recommend using pre-signed URLs. So we create our pre-signed URL builder. We need a bucket, a key, an expiration, and the HTTP method. And then when we want to download the image, we get our signer. We create a sign request and send it to the signer and handle it with the BF task. When we want to delete images or delete files from S3, we need to drop down to our low-level client, what we call our low-level client. So we create our delete object request, give it a bucket and key, get a handle to that default S3 client, and then call delete object. So So we talked about S3, and certainly you can use S3 for all of your delivery of files. But if you want to make those files available closer to your users, we can actually use Amazon CloudFront. So CloudFront is a CDN, content distribution network. We have multitude of POPs across the globe. So all you have to do is basically set up a CloudFront distribution in front of your bucket, and then you can access those files through the CloudFront, and that'll speed up your downloads quite a bit. So we all have a bunch of different features, additional features, on top of just basically basic CDN, including mobile device detection, geo-targeting, and cores. So again, all we have to do is we stick a CloudFront distribution in front of our what we call origin, and that origin can either be an S3 bucket or it can be a backend server. So if you want to cache data from your system, you can certainly do that with CloudFront as well. We have edge locations literally all across the globe. I think the only two continents we don't have POPs on now. But we have POPs all across the globe, so that this makes your data more available to closer to your users. So the recent enhancements, we added additional mobile device detection, geo-targeting, the cores. So if you want to serve JavaScript apps from CloudFront, you can do that and use cores. We also have protocol detection, and then some really great enhanced SSL features if you're worried about security. So that's CloudFront. So that allows you, again, to speed up your delivery of files. So now let's talk about how we can store shared data. So Cognito Sync is great for storing individual users' identity. Currently, right now, we don't have any shared data. So if you want to actually share global user data, we'll have to use a different solution for our application. So we have a DynamoDB object mapper. And this basically allows you to map individual items in DynamoDB and give them to individual users. So it simplifies the access to DynamoDB. You don't have to necessarily understand how to write query and scan operations or understand hash keys. You'll have to understand, at least at a basic level, hash keys and range keys, but it does simplify quite a bit. You basically just map your objects inside of your Objective-C or Swift classes to fields inside of DynamoDB. And then you just have to specify which one of those is your range key, your hash key and range key, and then you can query and load objects by that method. Additionally, we also have a geo library for DynamoDB. This allows you to store geographic data inside of a DynamoDB table, query it, and get results for nearby data points. Unfortunately, the logic for querying is pretty heavyweight. So we actually put together a sample Java server application that actually handles all of the queries and accessing Dynamo. And then you can access it directly from your mobile device through that server. It's just a little bit too heavyweight to kind of do on the device, so we have that server available. And that's available on GitHub. It's open source. You can extend it to do whatever you want with it. All right, so that's going to be the end of our section 2. Let me go look at my talking points here. So our mobile analytics service has a free tier. So you can do analytics is built on events. So you get 100 million free events a month. And then after that, after the free tier, it's $1 per million events after that. S3 pricing, it starts at least in US East, at around 0.3 cents a gigabyte. So it's great, pretty cheap storage. And then a half a cent for 1,000 put requests, so updates. And then 0.4 cents for every 10,000 gets. So it's much more cost effective to get files than it is to post and update. And DynamoDB's pricing is a little bit more complicated than I'd like to get into here, but if you have questions about that or anything else before we move on to our last section, now's your opportunity. Yes? Yes. Yes, so the question was about the Geo server, and yes, so the server that we have right now is a standalone application that you could run inside of Elastic Beanstalk, for instance, and we'll talk a little bit about that in the last section. And then you can run that standalone, or you could run it, you could add on additional functionality if you wanted to, but then you would call that from your mobile app directly. Any other questions? So unfortunately, the mobile SDKs don't currently support the document storage APIs. That's something that I know that we want to work on to add support for, but currently it's not in the mobile SDKs. It is available in the JavaScript SDK and most of the other server-side SDKs. It just hasn't made its way into the mobile SDKs yet. And that was about the JSON support. Sorry, repeating that for the recording. Any other questions? Okay, I'm actually going to hand it off to Sebastian for our last part. He's going to handle our part 3 for me.
Okay. So, good morning, everyone. Switching speakers, switching different accent to try to keep you awake for this last part of reInvent. My name is Sebastian Stormak. I'm a technical trainer. I'm based in Europe, so my job is to deliver trainings, architect, developer trainings, and sysops training across customer in Europe, Middle East, and Africa. And yes, I usually do speak French, as you might have already noticed with the slight touch of French accent I have. So, Bob went through the hardcore part of Cognito identity, Cognito sync. In this last part of this workshop, we'll revisit a bit the SNS push notification. I'll try to explain you how it works. I'll show you a demo. I will not do live coding. I'll let that for Bob's specialties. Oops. And then we are going to talk, we had a question about the GeoHash library and how we can wrap that on the server side. So I will explain how we did for this application, how we deploy that. And I will briefly talk about a service called Elastic Beanstalk that help you to deploy your server-side application very, very easily without having to take care of the underlying infrastructure for that. And we'll finish and wrap up a bit talking about another service we use in this application. It's called Kinesis. It's a service that helps you to stream flow of data, a lot of data, to do any type of real-time or close to real-time analytics on these data. So that's the structure of this third part of the workshop. So let's first start with push notification. Push notification are made through a service called SNS. It's a quite old service within the AWS platform. It's a publish and subscribe service at the origin. So a service that you can use to broadcast message to multiple subscribers. The core concept of SNS is a topic. You create a topic, and then you have applications that subscribe to that topic, and we have multiple ways to deliver the message from the topic to the application. You can register using HTTP, so SNS can call a web service for you. You can register using email. SNS can send an email for you for your notification about your infrastructure, for example. You can register using SMS text message on your phone, only for you guys having a phone number starting with +1, so American phone number only, doesn't work in Europe. So HTTP, email, SMS, queuing, you can also post a message to a queue, so where an application can fetch a message. And the last one that we did introduce roughly 1 year ago, 1 year and a half ago, is push message for mobile. So you can register mobile device to an SNS application or an SNS topic to send at very large scale push message to your mobile user. So how does it work? SNS will take care of the low-level communication with your push provider. In the case of Apple, with the Apple APN. So the first thing you have to do is to go to Apple's websites and create a certificate to enable the communication between SNS and the server from Apple. Once you have that certificate, you go back to the SNS console and you create an application. At the application level, you will give the details of your certificate, so the private key and the certificate. This will enable SNS to use the Apple API to talk and to send push message to your user, to your device. That's the first step of setting up the communication. This is something you have to do only once, obviously. You don't have to do that multiple times. I'm talking about Apple here because it's an iOS talk, but we also support Google. We also support Amazon for the Kindle Fire. We also support, it's not on the slide, it has been added very recently. We also support Windows, and we do support Baidu for the Chinese market. So Baidu is the Android version of for the Chinese market. So first step is to set up that communication between SNS and Apple in our case. The second step is actually on your device. So inside your code, you have to register for a mobile application. You have to call on the application object, the register for remote notification API from Apple, and your application delegate object will receive a call, dit register, and that call will receive a device token. So for every single device, you will receive from Apple a device token. So the second step for you as a developer is to associate that device token with SNS. SNS will create an endpoint, we call that an endpoint, for every single device. The endpoint will be authenticated or will be identified with an Amazon resource name, you know, this long internal ID that we use to refer to any object within Amazon. The Amazon resource name will be stable across the time. So if the user ever deletes the application from the device and reinstall the application later, the token might change, but the ARN on the SNS side stays consistent, stays identical. So you can track your user over the long term using the stable ARN name that we do provide you at SNS level. How do you register the token from the device to SNS? We leave you the choice for that. You have multiple options. The one we choose for the demo application is the device itself directly call the SNS API. So it's a very simple HTTP call, and the device itself calls the SNS API to register the device token to SNS. Of course, you don't have to take care of the low-level HTTP communication and the signature and the authentication for the API itself. We wrap that at the SDK level, and on the slide I have a code sample to show you how to do that with the SDK. The other option, if you want to do some clever stuff with the ARN, like associate with an identity, maybe associate that to your user profile on your backend systems, the other option that you have is actually to call your own backend, your own API, and from your backend, make the SNS call, make the SNS API to associate the device token with the ARN. Once you have that, SNS will take care of all the low-level details for you. So SNS will take care of the communication with Apple. SNS will also consume the feedback from Apple. You know that on the APN, one of the services that Apple is providing is feedback services. The feedback services give you the list of messages that cannot be delivered, maybe because the application was deleted from the device. So SNS will consume that automatically for you and will adjust the list of endpoints automatically. On your side, your next logical step is just to use the SNS API to send a message to the device. So it's just a very simple HTTP put to post the message to the device. Your application, your backend application, posts the message to SNS, and SNS will post the message to the device. You can choose, I explained that the token might change, but the ARN name on SNS stays consistent. So you can choose to send message to individual device, because every device has an endpoint on SNS, so you can choose to send to one specific device for one specific user. Think about a mail application, for example, or game application, where you want to notify the user that something happened in the game, or that a new mail message is there. You can also broadcast message to multiple users. Remember, SNS, at the very heart of SNS, it's a publish-subscribe mechanism, so you can create a topic and link multiple devices to one single topic. So when you will post a message to the topic, SNS will fan out the message, will broadcast the message to all devices registered to that topic. So if you want to communicate something to many of your users in one single message. Example use case that we see from our customer doing that is to group device, maybe per country, per geography, per type of customer, like my silver customer, my gold customer, my free customer, or by product that you're selling, all the user of that specific game. And so if you create several topics like that, just by sending one message to one of the topic, the message will be pushed to all devices registered to that topic. And of course, you can associate the same device to multiple topics. This device can be associated to one single product, a given geography, and a tier of user, for example. Does that make sense? Yep. Mm-hmm.
Is there any grouping of topics? Are there subtopics?
Is there any grouping of topics and subtopics? No, not at the API level, but this is something you can work out by yourself, by writing code. For example, naming, that would be one idea, or having a topic delivered to a queue that will fan out to multiple topics. You have to write a bit, and you have to write code for that. It's not built into the API right now. So how does it work at the code level? This is a code sample that you have to process on the client device when you do receive the device token. So typically it's in the application delegate. This is in the did receive, I forgot the name, but did receive token registration something. That's one of the delegate method that is called after you register your device for push notification. First line here is to get the SNS client. Then it's similar to the S3 API. You have to create a request object, give the request object to the client, and the client gives you back a response. So the request object here has just two properties. One of them is the application within SNS, so the identifier of the application on the SNS platform, and the other one is the device token that you have just received from that function call. So once you have that request, you call the create platform endpoint API on the SNS client, and it will asynchronously call you back with a response in the BF task, in the bold task. The task.result contains the response, and the response contains the internal AWS identifier for that device token, so the endpoint ARN, Amazon resource name. So let's see if it works. Oops, switching screen. Yes. I'm going to my SNS console here. And as you can see, I have one application defined in the SNS console, and I have two devices registered, so two different endpoints. This is the stable name I was talking about, the endpoint ARN. And this is the device token as it has been received by the APN from Apple. The first one is my iPad, the second one is my iPhone. The iOS simulator cannot work with push notifications, so you have to test that really on physical devices. So let's open my application on the iPad. It should be there. Yes, it's there. Let's start the application. Hopefully it should get all my nodes, public and private. Yes. Let's zoom that a bit. Okay. And now let's publish a message just to test if it works. So I'm using the console for that, but obviously you can do that from any type of application. So you can, most of the time it will be from your backend application. You will have some kind of Java code on the backend or Python code on the backend, and this is where you will push notification. Hello, iOS workshop. Let's take the two screens together, and let's just publish the message. And the application received the message from Apple, and for this very simple demo application, I'm just popping up an alert message to show you that we have received the notification. These systems, oh no, yeah, I always want to click from there, but no, it's just, I have to touch the screen, the physical screen. This is the systems that we are using also to make the Cognito synchronization, the push synchronization between devices. So I was hacking a bit while Bob was talking and managed to have it working in there. So I have on the right side the application running on the simulator on the Mac. On the left side, it's my real physical device. It's the iPod, which is there. I don't have the same public nodes in the two applications because the iOS simulator simulates a geolocation in the Bay Area close to San Francisco. The iPad here is physically in Vegas, so it only takes the nodes that are close to where we are, and I will talk about the geolocalization service in a moment. But that's why we don't have the same public nodes on the two devices. So if I create a node here, test push sync, and take a picture. Let's take a different one. Choose. So this will trigger a synchronization, and because push sync is set up, the iPad just received a notification. This time, it didn't display the message. It's a technical JSON message, but it initiates a synchronization to get the data from Cognito, and it refreshes the UI. So now I have the push sync with my localization somewhere in San Francisco, because this is how the simulator is working. It simulates notification on the Bay Area. So let's switch back there. Yep.
So the demo that you just showed, it was using the sync feature, the Cognito sync.
Yep, the last part of the demo was using Cognito synchronization, and Cognito synchronization is based on push notifications. This is why I combine the two right now. So whenever you sync on one device, a push notification is sent by Cognito, not by me, not by code that I wrote. Cognito will send a push notification to the device, and it's up to you as a developer to capture that notification and to do something useful, like to refresh your user interface. Yep. Any other question?
And that data sync, it's a silent push that happens. So can you make it not silent through data sync, or you have to explicitly write to SNS saying this should be a real push?
I'm not sure I do understand the question.
No, so my question was, like in the first demo, you had an actual
A pop-up.
right? And the second one was just data synchronization. And it was silent. It was using silent in the background.
Correct.
So you would have to manually code for a push notification that shows an alert, right? Data sync doesn't have any kind of alerting mechanism.
Correct. So repeat the question. I'll try to summarize it for the recording. In the first demo, the push notification trigger a visual dialogue on the user interface. On the second demo with the synchronization, the push synchronization, it was a silent notification. There was no visible user interface for that. That's actually an implementation choice. In both cases, you receive an SNS push message, and it's up to you as a developer of the mobile application to decide what you want to do with that. In my first case, I wrote code to pop up the dialogue. In the second case, I'm just triggering a sync and redisplaying, refreshing the data on the screen. But that's an implementation choice. You do whatever you want with the push notification. So what if you want to do things that are quite difficult to do on a mobile device itself? What if you want to do searching for public nodes that are close to the physical area where you are, the geographic area where you are? Or what if you want to do something which is too heavy to do on the mobile side? Most of the time, you will delegate this type of workload to the backend. So you will need, for most applications, you will need some kind of backend infrastructure, maybe with an API running there, with Java code, Python code, you choose. One of the examples for this application is the geographic library that helps you to find all the public nodes that were entered in proximity from where we are. Like Bob explained, we implement that as a Java library. So that's the first reason why I cannot put that on the device. We cannot send Java code on iOS. And it's quite heavyweight as well. So that's another reason to push that code back to the server. So what we did is just to wrap that library in a servlet and expose that through a very simple API. So the device calls the API to get the list of all nodes close to the place where we currently are. So how can you, as a developer, deploy such a very simple API, that one, without having to take care of all the low-level infrastructure for that? Because if you deploy an API, you need virtual machines, you need EC2 instance to do that, you need to install, let's pretend we are talking about Java here, you need to install Tomcats, you probably need a load balancer in front of that. If your application is extremely successful, which I wish for you, you might need several EC2 instances and maybe some auto-scaling to ensure that your fleet of Tomcat server will scale depending on the traffic that you have. So these are all low-level infrastructure details that you as a developer don't want to take care about. And we have a service to help you to do that. It's called Elastic Beanstalk. Elastic Beanstalk is a service that we provide you that helps you to deploy code. So it's a service that most of the developer loves because it really focuses on the application and on your code. It helps you to deploy code, and behind the scene, automatically, Elastic Beanstalk will create all the infrastructure required to run that code. So it will create the EC2 instance for you. It will install Tomcat for you. It will deploy your code inside Tomcat for you. It will create the auto-scaling group. It will create the load balancer. It will create some monitoring alerts with CloudWatch so that you as a developer don't have to take care of all these low-level details. But the infrastructure it creates are it's a normal EC2 infrastructure. It's a normal load balancer. There is no magical with Elastic Beanstalk, so you can get access to the EC2 instance. If you need to debug, for example, you can SSH connect to that. You will see the load balancer in your console. Elastic Beanstalk is a free service. You only pay for the resources that are created by Elastic Beanstalk for you. So you pay for the EC2 instance or for the load balancer that Elastic Beanstalk will create for you. It integrates with development tools. So if you are developing your Java backend using Eclipse, or if you are using a .NET backend with Visual Studio, with a plugin that install inside Eclipse or inside Visual Studio to help you to manage your environment directly from your development tool, so you don't have to switch between the console and your development tool. And my favorite feature of Elastic Beanstalk is the Git integration. If you are using Git as source code control, you can push your change directly from your laptop to Elastic Beanstalk. So you can just type git AWS push, and we have a small plugin to Git that will push the latest change to the running environment on Elastic Beanstalk. This obviously only works in a programming language where no compilation is required. If you have a build server, for Java, for example, you need to compile first, so the Git integration will not work with Java. But we do support not only Java, we do support 5, 6 different platforms. We do support Windows.NET, we do support Java, we do support PHP, Python, Ruby, Tomcat with Java, and Docker. So if your preferred programming language or platform is not there, you can always fall back to Docker. You prepare or you deploy your service inside Docker, and you just deploy the Docker container to Elastic Beanstalk. That's an option that we had a couple of months ago. Elastic Beanstalk will deploy your application. It will also keep track of the version of your application. So every time you deploy a new version of the application, Elastic Beanstalk will put a version number on top of that and will keep the previous version available. So if something goes wrong in your deployment, if you have a major bug and you need to do a rollback, Elastic Beanstalk will help you to do that, because at any time you can go back to the console or use a CLI script to redeploy the previous version, or actually any previous version of your application. Any question about Elastic Beanstalk? Anyone have already used Elastic Beanstalk? Oh, so not too bad. So in this demo application, we used Elastic Beanstalk to deploy the Java geohash library for DynamoDB and the servlet, the API wrapper on top of that, to provide a backend service for the demo application. Last service we would like to talk to you today is Kinesis. Kinesis is a service that has been introduced a few months ago. It was last year, 1 year at reInvent last year. It's a streaming service. Most of the time, for many different applications, you have a requirement which is to ingest a lot of data from many different sources. A source might be a mobile device. If you have millions of devices, this device might stream real-time data about application usage or user usage. You can also think of use cases like Internet of Things. You are deploying sensors, and all these sensors, hundreds of thousands or millions of sensors, are sending data to your backend. Another use case of streaming would be log collection. Let's imagine that you have a very large fleet of EC2 instances, hundreds, thousands of EC2 instances, and every of these are publishing logs. You need some backend infrastructure to actually receive, ingest the logs. And doing that reliably and doing that at scale, it's a quite difficult problem to solve, because you need to scale your ingestion platform depending on the size of the volume of the data that you are receiving. And this is a problem that Kinesis tries to help, to solve. So Kinesis is a stream ingestion system. So it's a service that runs on our site where you can publish information, any type of information. So we have a very simple put API to let your device or your sensors or your EC2 instance, whatever, to push information to Kinesis. And Kinesis will scale to receive all this information coming from all your different devices. And we have currently many different streams, thousands, probably more than that, streams running on Kinesis that ingest a large volume of data every day. So Kinesis will receive that and will store that for 24 hours. And then it's your job as a developer to write a Kinesis client application. The client application is actually the server-side application that will consume the data from Kinesis and do whatever you want to do, what you need to do on this data. So typically, you will receive this data and you will run some kind of real-time analytics or fraud detection or whatever your business requires on the data ingested by Kinesis. That's actually the hard part of programming. It's the application that will consume the data. So we did for that demo, for this demo, the easy part, which is push data to Kinesis from the mobile application. So the mobile application push all its log, all the application logs to Kinesis. So later we can write a Kinesis client application that can consume that and extract information based on this log. So the Kinesis communication is wrapped in the SDK as well with a Kinesis connector. And the Kinesis connector will actually batch the request for you automatically. So we have an API that lets you insert data to the connector. The connector will not immediately send the data to Kinesis. It will collect a few of the data, and once the buffer is complete, or when you want to trigger the push, the connector, the client connector, will push the data. How does it work? You create a Kinesis recorder class, and you can fine-tune the behavior of the recorder. You can give us the size of the cache or the maximum age of the data in the cache before pushing the data to Kinesis. Your application will receive a notification when the cache is full, so you can register to listen for that notification and react to that notification. How do you send an individual item to the cache? You create your data using an NSData class, so it can be any type of data. It might be text file or binary. And then you call the save record API on the Kinesis recorder with just one or two parameters, of course, your NSData, and the name of the stream. You might have multiple streams in Kinesis. When your cache, local cache is full, or when you decide it's time to submit the records to Kinesis, you just have to call the submit all records to the Kinesis recorder client application. So from a client perspective, it's extremely easy to interact with Kinesis. Just 3 or 4 lines of code, and you can send any type of data to Kinesis. For the server-side programming of Kinesis, we have libraries that helps you to do that. We have a Kinesis client library, one in Java, one in Python. So these are libraries that handles all the low-level details of reading the stream data from your Kinesis stream. This library can scale to multiple EC2 instances. It will automatically scale depending on the number of data available in your stream. And this library will take care of all the low-level multi-threading programming to ensure that multiple threads are spawned to read the data from the Kinesis stream. If you want to move data from Kinesis to another system like S3 or like DynamoDB or Redshift, we also have a Kinesis connector library. So beware of the name. We have Kinesis client library, KCL, and Kinesis connector library, KCL as well. And the connector library, it's like a workflow, actually. It's a library that structures the reading from Kinesis, the transformation of data, the filtering of data, and pushing the data to another system. So it's a set of interface, and you have to implement each of these interfaces. You have a filter interface, you have a client interface, you have a filter interface, you have a push interface, and you as a developer needs to implement all these interfaces to create a kind of workflow that will read, filter, transform, and push the data to another systems. Once again, DynamoDB, S3, Redshift are the likely candidates where you want to store the information coming from Kinesis. And if you are using Storm, we have also a connector for Storm. They call that a spoit. That's the pronunciation in English. A Storm spoit. It's not easy to pronounce for me. So if you are using Storm, you can also integrate Storm with Kinesis. Any question about Kinesis? Yep.
Sorry, it's a basic question. So between SNS and Kinesis, what are the considerations when you use, say, it pops up like SNS or Kinesis?
So the question is, what is the difference between SNS and Kinesis? SNS is a PubSub service. It's designed to send a message between application or to human being with the push notification. Kinesis is more a streaming system that handles extremely large scale stream of data. So the size of it or the scalability of the two services is very different. With SNS, you will send occasional message in a one-to-many way, so one message sends to multiple mobile devices. With Kinesis, it's the other way around. You have multiple devices that are sending message to Kinesis, and then you have one application that will collect, aggregate all these messages to do some kind of analytics on the stream of message that you receive from the devices. So it's the other way around. Yep.
So it's sort of a standard best practice used in mobile analytics. Do stuff like how long does it take to send images up, what's my average latency, how many times does a user click this, etc. And then you use something like Kinesis to do the entire device logs to determine all that other kind of.
That would be one use case. So I repeat the question. Mobile analytics will also collect events from your devices, and actually you can implement something like mobile analytics yourself on top of Kinesis, for example. Yeah, Kinesis can be used for roughly anything, not only in the mobile context, it might be for the Internet of Things context, it might be for just log collection. You define the use case. Mobile analytics is a higher level application that really analyzes the user behavior. And yes, we can feel that behind the scene, mobile analytics also receive a huge stream of events from multiple devices. When you push data to Kinesis, is there any metadata capture? Let me think, I'm trying to remember the low-level API. There is certainly, there is a Kinesis record ID which is generated on the server side, which is guaranteed to be in increasing order, so the order of the message is preserved. For the timestamp, I'm not sure if you have to add that, or if we do add that, do you know? I'm sorry? I don't believe so. No, I think you have to add the timestamp by yourself. We can have a look at the low-level detail, the API for Kinesis to see what type of data we add. The order of the message ID, that's for sure, that's something we take care about, yes. That's one of the advantage of Kinesis as well. We can give you an increasing number, so you can be sure about the order of the message, and you can collect the message in the right order. Let's go back to Cognito and an advanced scenario for Cognito identification. Bob told you about Cognito ID and how you can use Cognito ID to authenticate your user and to assign permission to your user, authenticated user or unauthenticated user. And we show you the example of login with Amazon. We also support login with Facebook and login with Google. But a very frequent customer request that we had is, what if you have already your own authentication system? You have already your own backend to authenticate your user. And for many different excellent reasons, you don't want to send your user to Google, Facebook, or Amazon for user authentication. You want to do the authentication yourself. So we recently added that capacity to Cognito as well. And let's see how it works. We call that developer authenticated identities, because obviously you, the developer, are the one responsible then to authenticate your user. So we have, on the left side, we have the mobile device. We have your authentication server. So that's a server that runs on your side. And the purpose of that server is to authenticate your user. On the right side, we have the Cognito service, and we have the security token service on AWS. That's the service which is responsible about generating an access key and secret key, the credentials that you need to make an API call. How does it work? From the mobile application, you implement your login functionality. How do you implement it? I don't want to know. That's your implementation details. You authenticate the user with a username, password, with a certificate, with biometric, facial recognition. I don't want to know. You just authenticate the user. Once the user is authenticated, on the server side, you need to make an API call to Cognito. And that API call is get OpenID token for developer's identity. So to that call, you will give your user ID, your server-side generated user ID for the user that you have just authenticated. Cognito will answer you with the Cognito ID, so the stable identity generated by Cognito, and an OpenID Connect token. So you respond to your mobile user with the Cognito identity and the token that you have received from Cognito. Then, using the SDK, and using the credentials provider class that you saw during the live coding earlier today, you call STS, and basically you ask STS to receive an access key, secret key, in exchange of the OpenID Connect token that you have just received. So basically you tell STS, hey, I have an OpenID Connect token here, please exchange that against an access key, secret key. This is one single API call, assume role with web identity, and the SDK is doing that for you when you are adding the token to the credential provider class. That call will happen behind the scene automatically for you. So STS will receive and consume the OpenID Connect token, will verify, of course, that the token is valid, that you didn't try to do something nasty on that token. And if everything is okay, it will get you back an AWS access key and secret key. And once again, that access key and secret key is encapsulated in the credential provider object provided by the SDK. So you don't have to really get access to the string representation of the access key, secret key. That access key, secret key will be used to sign all the other API calls that you will do. For example, to fetch your picture on S3, or if you want to make a DynamoDB call directly from the device, that access key, secret key will be consumed by the SDK, by the client services of the SDK to call any API on the server side. Is it clear? Sometimes you have a developer server, you have a server to provide user identities on your side, but you still want to delegate user authentication to third-party service. And one example might be LinkedIn. As we don't support natively LinkedIn, how would it work if you want to authenticate your user with a service that we do not support in Cognito? You have to let your user go to the third-party service to make user authentication. How they authenticate over there, that's their problem. We don't want to know. But anyway, if the authentication is successful, LinkedIn, in this case, will return a token to the device. Then the device needs to talk to your server, so to make a call to your user identity server and give the access token it just received from LinkedIn. Your server will then check the validity of that token with the identity provider. So it will make an API call to LinkedIn to see, hey, is the token that I just received, is it a valid one? And if it is a valid one, you can once again call the getOpenID token for developer identity, on Cognito, and you give us a parameter, the token that you have received from LinkedIn. And just like in my previous example, Cognito will answer you with the stable Cognito identity ID and an OpenID connect token. Your server will give back that Cognito identity ID to the mobile application and the token. And whenever a client, SDK class, the S3 client, the SNS client, the DynamoDB client on the SDK will need to access one of the services, we will have a call to get an access key, secret key, and the class will give the OpenID connect token to STS. STS will validate that with Cognito and will answer with an access key, secret key. So basically, you can integrate any type of identity provider by using that mechanism and the server side on your side, and that Cognito API get OpenID, I always forget the name, it's too long for me, get OpenID for developer identities. Questions? Wow.
You support things like SAML, single sign-on?
So the question is if we do support Samuel, SAML, single sign-on. And I have a mixed answer here. At STS level, so the green service on the bottom right side of the slide, yes, this service has an API to consume Samuel token. And usually we see our customer using that in an enterprise identity federation single sign-on scenario. So you authenticate your user on your desktop user, for example, with your Active Directory. The Active Directory generates a Samuel token, and you can consume that Samuel token in exchange of, and receive in exchange an access key, secret key. On the Cognito part, we do not support Samuel yet, but we are always listening to customer feedback. So if it is important for you, if you have a use case for that, let's talk about that and let's see. So that was a quite hardcore session. Identities question are always hard, and single sign-on scenario, it's always hard. Yep?
Is there somewhere that code would be available?
Yes, the code of the application will be eventually available on GitHub. So we have a GitHub repository with all the AWS SDK samples, and it will be there. I cannot give you a date as soon as we can. We have to clear out first some bugs in the code and get legal approval and all the internal approval to get that code out. But yes, the intent is to publish the code. So let's recap about all the things we talked about today. When you are developing your application, your job is to make sure that you provide your user the best user experience and the best application, and not to focus on all the undifferentiated heavy lifting, all the things that I call the plumbery, all the low-level stuff that all applications have to handle correctly. And we try to help you for that by providing different services and wrap these services in a mobile SDK. One of the services, and we talk in length about that one, is Cognito. Cognito has two parts. One of them is the user authentication, to help you to authenticate your user and to manage the authorization that the user will have to consume other AWS service by using the IAM policies. So you can restrict what an authenticated user will be able to do on the AWS services. And the other side of Cognito is the synchronization. With Cognito, you can synchronize up to 1 megabyte of user profile data between multiple devices, like a tablet, a smartphone, or even a website, and keep a consistent user experience across these multiple devices or these multiple applications. Another thing is that most of the mobile application is doing is to collect behavior, user behavior, to track user retention and to analyze the user flow within your application. So we have a service that helps you to do that. It's called Mobile Analytics. It's extremely simple to use, as Bob demonstrated. You just instantiate the class, and it will automatically track when your users are starting the application, leaving the application, coming back. And you can also generate custom events if you want to track some purchase within your application, for example. You can add custom events inside your application to do that. On the backend side, we have services that help you to store state on AWS without having you to rely on a server-side infrastructure to do that, or your server-side infrastructure to do that. We have S3, the file storage service, the object storage services, where your application can upload content and download content, typically picture, video, but it can be any type of content. And if you have large-scale access to S3, we have CloudFront, the content delivery network services that will cache this content on one of the 52 edge locations we have on this planet. So the content will be served by a network location which is physically close to the location of the user, instead of sending your user request back to your backend infrastructure. If you need to send push notification to your user, you can use SNS to do that, either to an individual device or to multiple devices by using a topics. And you also have direct access to DynamoDB, the NoSQL database from Amazon. So your mobile application can use the DynamoDB API to interact with server-side content, and you can restrict access to that content to specific keys. So for example, you can create policies to ensure that user will be only able to write items with their user ID as a key, and to not write items with someone else's user ID. And last but not least, if you need to stream large amount of data from a large volume of device, you can use Amazon Kinesis to stream the data. Up to you then to write a client application, which is actually a server-side application that will consume this data and compute some analytics or some user behavior, some fraud detection, whatever type of information you want to extract from that stream of data. If you are serious about mobile development on AWS, subscribe to the AWS Mobile blog. We have an RSS feed for that. There are weekly updates on that blog with very good articles and best practice about how to use the client-side SDK. And also subscribe to our Twitter handle, AWS for Mobile. If you have specific questions, we have the forums where you can ask your question. We have many people from Amazon that are monitoring this forum. The engineering team, you do? Yes, thank you. The support team, the training team, so you can get answer quite quickly. And Stack Overflow is always a very good community also to ask a question or to get answer when you are looking for specific answers. And we also monitor Stack Overflow. We also answer questions on Stack Overflow. That's correct. Thank you. And the two GitHub repositories, it's /AWS and /AWS Lab. The SDKs are open source. You can download the source code from the SDK. Sometimes it's interesting to have a look at the code to see how things are working if you want to understand internal behavior of the SDK. And we do publish more and more, and hopefully even more in the future, code sample for these SDK on GitHub as well. And that's it for Bob and myself today. If you have more questions, we are happy to take them. Otherwise, we wish you a very happy end of the conference and a safe travel back home. Thank you.